This lecture is all about communication, but I know I've got my work cut out tonight. With the ability to make video calls to anyone, anywhere, where could I possibly call that would amaze you? Australia, Antarctica, how about space? Station, this is Danielle from the Royal Institution in London. How do you hear me?
I hear loud and clear.
Great. Hi, Samantha. I'm able to talk to you just using my mobile phone from here, but I'm guessing you can't use your mobile phone from up in space. So how do you communicate with your friends and family?
It's funny that you mentioned that because I've been up here for about 3 weeks and I have never thought about my mobile phone once, while when I'm on Earth, I'm constantly checking my mobile phone. So I guess I am getting over my mobile phone addiction. But we are not disconnected from our family and friends up here. We have access to the internet. It's somewhat slow, but we do have it. We can even see them. We have a two-way video conference where we can see them and they can see us.
It's really wonderful that we can hear and see you, but that's just using two of our senses. And so wouldn't it be great to be able to reach out and touch somebody and so use our other senses to communicate?
What you say is interesting, to be able to see the world through somebody else's eyes or even being able to touch them. I think there is an interesting technology demonstration which is co-developed by ESA, where people on the ground can see what the astronaut sees and the astronaut can have information that can be sent from the ground.
Well, thank you very much, Samantha. It's been great talking to you.
Bye-bye. Thank you.
Lectures, I'm going to be hacking 3 everyday components that we take for granted every day: the light bulb, the telephone, and the motor, and showing not only how they work, but what problems we can use them to solve. My name is Danielle George, and I'm a Professor of Engineering at the University of Manchester. Now, tonight is all about communication, and my starting point is the telephone. When I spoke to Samantha earlier, I was genuinely using this mobile phone. I was just using my ordinary mobile phone. It was amazing. But wouldn't it be great if we could not only hear and see someone in space, but also reach out and touch them? Take a look at this. This is the most human-like robotic hand. It has tiny motors that accurately replicate movements. And as you can see, we've pre-programmed it to show you what it can do. So it can wave at us, certainly move all its fingers. It's trying to wave at us there. And it can say goodbye to us as well. I really like it. And I can also try and tell it what to do. So we can't just see what it does, but I can tell it what to do with this sensor glove. So what I have here is a glove that is filled with sensors. And it's an amazing glove. It gives me perfect control of this hand. So hi. Who would like to come down and hold my hand? Yes, you there. Okay, round of applause, please. Okay, just come around this side. What's your name? Beth. Beth. Okay, Beth. I want you to just hold my hand. So instead of shaking it, just hold my hand. Maybe like that. That's it. Now I'll try and hold your hand there. So as if we were holding hands. Is that as if we're holding hands? Yeah? I'm not squashing your hand, am I? No? But you can feel me there, yes? Yeah. Well, it's nice to meet you, Beth. Okay, thank you very much, Beth. Now, I wonder what Alexander Graham Bell would have thought of that. Because in 1875, he invented a very simple device that could turn electricity into speech. He could talk with electricity. And what we've done here is recreate his very first experiment. So what we can see is a simple transmitter, which is actually just a polystyrene cup here. And then there is a membrane here that we can talk into that will vibrate when sounds are directed at it. Then at the other end of this wire, we can see there's a container, and this wire is barely touching some vinegar. Now, Bell used a different water acid solution. We're just using vinegar. So as the voice-driven membrane causes that wire to advance and retreat ever so slightly in that liquid, the resistance in my circuit will increase and decrease. And it will increase and decrease in perfect step with the sound that's coming from here. So this change in the current will reproduce my original sound. So I need someone to be able to say the sound, and we're going to listen to what the sound was. Okay, yes, you there. I think you had your hand up first, definitely. Okay. Oh, we've got two. We've got two people. I promise to come back to you for the next one, okay? Because two of you came up at the same time. Okay, what's your name?
Felix.
Felix. Okay, Felix. What I want you to do is to come round to this side for me, please. And then we can get in nice and close. And what I want you to do is say that message nice and clear, not too loud, but nice and clear, okay? And I want you just to keep saying it, repeating and repeating, so that we can pick it up using this receiver, okay? So speak nice and clearly into there. Let me just move it towards you there.
Come here, Mr. Watson. I want to see you.
And I'm going to go up on this side.
I want to see you. Come here, Mr.
And it's really, really faint, but this is a very, very old experiment. But can you hear that? Put it nice and close to your ear. So you can hear lots of sort of feedback with it. But can you hear a really faint voice in there as well? What is it that he's saying?
Come here, Mr. Watson, I want to see you.
Come here, Mr. Watson, I want to see you. That's brilliant. Thank you very much. Thank you very much for your help. That's great. Thank you. So we just heard there, come here, Mr. Watson, I want to see you. And this was the very first message that Alexander Graham Bell transmitted in 1875. Now, I want to honour this great invention that we take for granted every day by setting ourselves a grand challenge. Let's do something amazing with communication that Alexander Graham Bell could never have imagined in 1875. So, drum roll, please. Rather than communicating by sound, tonight we'll be attempting to use all our senses when we beam a special guest into the theatre by hologram. In the future, wouldn't it be great to communicate over long distances in a much more real-life way? I live in Manchester, and why shouldn't I be able to have a great communication experience with my grandma, who lives in Newcastle, as if she was in the same room with me? I want to be able to speak to her, I want to be able to touch her and hug her, or even sharing a meal with her. How close can we get to that dream tonight? To help me out with this, we have TV presenter Dallas Campbell, who's done lots of science programmes, and you may have seen him on Bang Goes the Theory or Supersized Earth. Now, he's currently in a London studio, and I'm not quite sure if we can hook up to him now, but we'll just wave and say hi. Hi, Dallas. Now, hopefully, we're going to beam him into the lecture theatre and have the ultimate communication experience with him. Now, this might sound an impossible challenge, but I'm an engineer, and impossible challenges are what I do best. But when I have a big problem and I can't solve it, I need to think of a way of breaking that problem down into little problems that I can solve. So, first step, we need to capture our high quality image. Then we need to send that information from the studio. Then we need to be able to project that image right here next to me. But that's not enough. We've seen we also want to be able to shake hands with Dallas. So we need a way of transmitting touch. Then, can we bond with all our senses and include taste and smell? Right, step one. Question for you. We're capturing images. What do we have lying around the home that can capture an image? Yeah. A camera, yes. You have cameras, and we have a lot of cameras on our smartphones these days, don't we? So we could use just our smartphones. So actually, this challenge is starting to feel a little bit easier for me now. Now, I'm going to show you some really cool ways that you can hack these cameras. But to do this, first, we need to know a little bit about how they work. Your phone has something in it called a CMOS sensor. And this is it right here. So it's sort of stuck behind your camera lens. Now, CMOS stands for complementary metal oxide semiconductor. Now, knowing that doesn't actually help us to understand it, but I'm going to use these 4 buckets to help us understand. Now, actually, this chip is a CMOS sensor, but it's actually 8 million sensors. And they're all arranged in a grid. So we have 8 million pixels, or picture elements. And what happens is when you take a photograph with your camera, the scene is divided up across those 8 million pixels. But 8 million pixels is a bit too much for me to think about, so I'm just going to take 4 pixels. So I'm going to look at the top left-hand corner of my image and take those 4 pixels from there. So I need 4 volunteers to be my pixels. Now, I'm definitely choosing you. Yep, so you are the first one. Yeah. And the person next to you as well. Yeah, so you too. And I'll take guy with the shirt, checky shirt. And you with the glasses there. Yeah, okay. Thank you. Okay, what's your name? Hannah, okay. You stand in front behind bucket 1 here, and you can have those 2 electrons. And you're next. What's your name?
Joshua.
Joshua, okay. You stand behind bucket 2, and there's your 2 electrons. And next, your name?
Alex.
Alex, behind bucket 3, and you come round. And your name?
Alistair.
Alistair, okay. So there's your 2 electrons, okay? So you are my 4 pixels. But what do pixels actually do? Well, when a pixel gets hit by a photon or a light particle, it releases an electron. So let's try this. When a light particle hits a pixel, it releases an electron. Brilliant, well done. Very good. Good. And what just happened there was the electron was released from the light particle and is now in a storage device. And this bucket represents a capacitor which stores that charge. So if another light particle hits a pixel, it releases another electron. Excellent. So I should be able to hit all of my pixels and they release an electron. And then pixel 4 is a particularly bright part of the image, so it gets hit with more light, so 2 electrons end up in the bucket. So that when the shutter is closed, the chip reads the capacitor charge to see how bright the picture actually was. And you can keep your additional electrons. Thank you very much. You were very good, pixels. So now I need to just count up how much charge has been stored in my capacitor. So I have 2, 1, 1, 2. So if we then say, okay, these are the top 4 left-hand corner of my picture, we can then assign numbers to the rest of a picture and say, okay, well, we've got a large number, 8, here, and we'll say that's a lot of light. So a lot of light is on that part of the picture. So we'll say that's white. Then we have zeros, so we can say, well, there's not a lot of light there, so we'll have that as black. And then everything else is a grayscale in the middle. So that when we assign a grayscale to the rest of our image, we get back Alexander Graham Bell. Now, this is black and white, and we live in a world of colour. So we've got filters that, in our cameras that are placed over the pixels in red, green, and blue. And when you combine all of that data, the camera can make a pretty good guess at which is the dominant colour. And that's basically how digital cameras work. Millions of tiny light detectors to make one sophisticated sensor. And if we think of our phone as a light detector, can we think about using our phone camera in other ways? Can we use our camera to take extreme close-up photography? Well, to show you that, I'm going to show you a very, very simple hack, but I'm going to have a bit of a rest. I'm going to come and have a little sit down with someone up here. So, I'm going to come and sit next to you. That's okay? And what's your name?
Ruben.
Ruben. Okay, Ruben. You can just help me with this simple little hack we have, okay? So what we have here is our mobile phone, and we just have our camera here, okay? And what we're going to do is just take a lens from a disposable camera, so a nice cheap disposable camera. And then we're just going to use some blue tack to attach a lens onto our camera. Okay, so if I give you this, Ruben, okay, what you can feel there, you can feel one's got a flat side and one's slightly raised.
Yeah.
You feel it, yeah? What I want you to do is just take this blue tack and attach the flat side to the camera lens. Now we are using blue tack, but you can use anything you like. But obviously we can't get it right on the top because we need to look through that. So just around the edges and then just press it down. And I want you to take that and get as close as you possibly can to that coin with the camera. That's it. There, can you see that?
Yeah.
Yeah. Can you see how close in you can get? You can actually even see all of the lettering. So I'm going to take a little photograph of that. And then if we just want to hold it up to just the cameraman here, just so everyone else... Can everyone see that? See how close we've managed to get to it? So you can actually see all the writing on the coin. And if you try that without the lens, you'll find you can't go anywhere near that sort of level of information. Thank you very much for your help. Now that's just a nice, easy, simple hack that you can do at home. Now cameras like this are very useful for taking 2D images. If I take a photograph of a horse, my phone doesn't know it's a photograph of a horse. It just knows it's a series of pixels or picture elements. So if we build a hologram from high-resolution pictures on a camera, the computer needs to be able to start to process that image in some way and make some simple judgments about that scene. We need to be able to separate the person from their background so we get a nice, clean hologram of Dallas. Now, here's a hack that can do just that. But this is one hack you really, really shouldn't try at home. In fact, this one is so dangerous, we can't even do it in the lecture theatre. It's so risky that I can't ask even any of you to volunteer. So one of the production team has volunteered. So please welcome the production team, Lucy. Hi, Lucy.
Hi, Danielle.
How are you feeling?
Got to admit, I'm a little bit nervous,
Yes.
but I am going to put my trust in science.
Good, that's what we like to hear. Okay, so if you want to go off and get yourself ready, Lucy, Okay, now, as I said, it's too risky even to do in the theatre. So what's going to happen now is if Joe, the cameraman, follows me and you guys can watch on the big screen, what's going to happen is we are going to go backstage and we're going to see the firing range that we've set up back here. And thank you, I'm going to need my safety goggles as well. So let's see what we have. So hi, Sasha.
Hi, Danielle.
Thank you very much for showing us this. So what we can see is 2 paintball guns that have been hacked. And they're attached to 2 motorized turrets here. And both of these guns are capable of firing 10 balls a second. So if I stand well back, Sasha is going to show us what they can do. Now, I wouldn't like to be standing in front of those, but if I did, I should be safe, because attached to this rig is just an ordinary webcam, which is attached to a computer. Now, this computer analyses the screen for the shape of a human body and tells the guns which areas to avoid on that board. So where's Lucy?
Here.
Great. Okay, are you all ready, Lucy?
Yes, I am.
Okay, right, so if you stand in front of the board, now we should be able to see Lucy on the monitor. We are going to take an image of you now, Lucy, so stand very, very, very still. Okay? Now, the computer is analysing that image and drawing a line around where it believes Lucy is standing. Okay, that looks about correct. Yes? Okay, now the software then tells the guns to fire all the way around Lucy's body, but hopefully not straight at her. So, Lucy, are you ready just to pull that green down from behind you? Okay, this is it. I think this deserves a countdown, everybody. So from 5, and I'm going to get out of the way. Ready? 5, 4, 3, 2, 1, fire! Wow, that looked amazing. Come on through, Lucy. How was that for you?
A little nerve-wracking.
Yeah, I don't blame you. So I'm not surprised. So we can see there's a bit of an outline, but we see it's also caught you a little bit there. And you might have a little bit of a bruise there tomorrow. Yeah. But on the whole, you've come out pretty unscathed. Yeah. So thank you so much for putting your trust in a computer program. And thank you very much, Sasha.
No problem.
Thanks. Now, I hope that looked good out here, because that looked fantastic in there. Now, as well as being a lot of fun, this proves that a computer doesn't have to capture the whole image. But with the right software, it can start processing that image. It can pull out 2D shapes or objects, or Lucy in this case, and tell other things how to react differently. Now, this is going to be crucial in creating our convincing hologram. So we should be able to see Dallas in position in the studio. We have a camera that's lined up to extract a high-quality image of Dallas from that background, so we can send the hologram of just Dallas and not the surrounding furniture. So step 1 complete. We've managed to capture an image of Dallas. Step 2, how do we send that image? We've got to take that hologram of Dallas and send it to right here at the Royal Institution. Now, this probably sounds like it should be the hardest bit, but actually, it's probably the easiest. We just use the internet, right? Just use the internet. It's so obvious that we just take for granted every day. What is actually going on? How do messages get sent from one side of London or one side of the world to another? Well, we use something called fiber optic cables. And you will be very, very familiar with fiber optic cables. We use these all the time. And it sends information, digital information, down a cable in beams of light. So you can see I'm just shining a torch down this cable and you can see the light at the other end. Now this was actually originally developed in the 1950s for doctors to see inside human bodies. But in the 1960s, engineers then used it to transmit phone calls at the speed of light. But we've just seen there that I shone a light and it came out of the other end. And this cable is bending, it's twisting and turning. So how's that working? Because don't we all know that light travels in straight lines? So how is this working? Well, let's recreate an experiment that John Tyndall did in 1870. Now, I need one volunteer to help me with this. So you right in the middle there with the jumper on. Yeah. Okay, what's your name?
Lucy.
Lucy. Okay, if you want to stand this side, Lucy. Okay, now I'm going to explain to you what I've got here. What we have is a bucket, and if you just look inside, Lucy, what we have is just some reflective film inside here, and also we have a little hole, and you can just see the inside. We have a hole here, and we have it taped over at the moment. So if I just take this tape off for now, we can see we've got a little hole in our bucket. Now, I'm going to give you this tile, and what I'm going to do is shine this torch in here, and then I want you to put that tile on this side where you think that light is going to come out. So yeah, it's coming out in a straight line, and that's what we'd expect, isn't it? But let's try it again and put some water in our bucket, and let's see where the light goes then. So if we just add some water to our bucket, and then what I'm going to do is just shine the light again. You get ready with your tile. This is going to catch the water down here, okay? And then we'll see where the light goes, okay? Okay, so if I then remove my tape, oh, we've got a lot of water now. And if I shine my light in there, and then if you just try and decide where that should be. Bring it in. You see the beam of light now? Yes? So the light is actually part of this water. So we're actually bending the light. And the way that's working is the light is in that stream of water. So we're using the boundary of the water and the air for that light to bounce off. So we're bending light. It's amazing. And this is the principle of how fibre optic works. So if I want to be a fibre optic cable, I'm going to have to flash this really, really quickly, just like digital signals. So how fast do you think I could flash this? Do you think? A few times a second, maybe? Yeah? I'm not very fast, am I? Because one of the fastest demonstrated fibre optic cables can flash 5,000 billion times a second. That's fast, isn't it? It's faster than my broadband. That means you could download a movie in 0.2 of a second. That would be pretty good, wouldn't it? Yeah. That's great. Thank you very much for your help. So step 2 complete. Sending our hologram across London won't be a problem. But projecting it right here on the floor beside me might be. Fooling our brain into thinking it's looking at a 3D image is actually quite tricky. You need to ensure that each eye sees a slightly different image, just like they do in real life. And that's our step 3. How do we project a hologram in thin air? Well, one way of doing this is to use a virtual reality headset, just like this Oculus Rift one. And now Rob from Go 8-Bit has brought his headset in here, and what we can see in here is a high resolution screen and 2 lenses. Now, the left eye will see one version of our image, and the right eye will see something different. And then our brain will combine that image to make a 3D scene. So that when I move my head, sensors would detect that movement and adjust the images, just like in real life. So one solution could be put our hologram in the virtual world. But how believable is this experience? Well, to answer that, please welcome Rob and Steve from Go 8-Bit. Hi, Rob. Hi, Steve. Okay. So, Steve, how does this work?
Well, we thought rather than tell you, we're going to show you. So if you can find us a guinea pig, we'll pop someone on there and show you.
Brilliant. Who
Lots of
would
hands
like
up.
to be a guinea pig? I think you there who's waving your hand. Yeah. Okay. All right. What's your name? Xander. Okay, Xander, what you need to do is just stand here and turn and face everybody like that. And Rob's going to put the headset on you. Just stand a fraction back, Xander. Just a fraction back.
Perfect.
I'm just going to tighten it for you. Is that all right? Can you see? Yeah?
Good to go?
We just need to get Xander a little bit closer to here. Sorry, Xander. Okay, we ready?
Nearly. There's one more thing, just so that everybody can see what you're feeling. I'm about to hand you a tray of champagne glasses. So can you hold your hands out? That's it, a little bit wider apart. Not your fingers, yeah, that's it. Now turn your hands towards each other. Very good. And I'm going to hand you the tray now. You move your hands in a little bit, you'll feel the tray. Move them towards each other. That's it, grab hold of that, there you go. Now I wanted to make them in a pretty pattern. I've got 10 and 9 looked prettier. So what I'm going to do, I'm just going to pop one on there.
Ooh.
So you've got the advanced test.
Wow-wee.
Right? Hold them very still. You're doing really, really well. In fact, that's a bit too cruel. Let me pop that there. We're going to send you on the roller coaster now. I'm going to see how you get on, okay?
Can you see that roller coaster?
You're doing very well. So the first thing we'll do, just to show the guys how this works, if you take a look to your left now, the other left, but that works too. Very good. You'll see that as he turns his head, he's actually seeing around him in the world. If you take a look down to your left, you'll see a little tunnel further to the left. There's some little houses, and over to the right, you should see the castle wall. Very good. I'm amazed that you've still got all 10 of them standing up.
I know, me too.
If you look to your left again, see that ladder? Yeah, you'll be fine. And if you look to your right and down now, you should be able to see a little river. There's rapids and the sea in the distance. Very good. And actually, if you look down below you, you'll notice you haven't got any legs. But don't worry, yours are still there.
Oh, we've lost a few.
Don't worry, you've still got 8, 7. I can't count. 9.
6, 7. You've still got 9. You're doing brilliantly.
You're doing really well. They gave you 11, then I can't count. But well done. Right, take a look to your right and your left one last time, just to take in the surroundings and enjoy it, because it's going to get horrible in a minute. But don't worry, because Rob's going to look after you. You might want to look down a little bit as you grab the edge. And can we get a ooh? Very good.
Oh, you're doing fantastic.
Oh, okay. You're nearly there. There's just one more challenge. They haven't quite finished the tracks. You've got a jump coming up. You've still got 4 on there. See if you can keep them on when you go over this final jump.
Whoa.
Very good. And land it.
Excellent.
That's not bad. With 4, we'll give him
That's
that.
brilliant. Well done.
I'll take that off you now. We'll get you out of there.
That's fantastic, Xana. How did that feel?
It's actually on a roller coaster, except
Like-
without the wind.
A real roller coaster, but without the wind, really, yeah? Well, let's turn around and see how you actually did, because we should have a little bit of footage here to show you with the roller coaster, and then what we were actually seeing with you as well. So that was you just going over the top there. So you've still got all the glasses there. You did so well, Xana. No, it looked fantastic. No, you did very, very well. Brilliant. Thank you very much, Xana. And thank you to Rob and Steve as well. Thank you very much. Sorry. Now, that was unquestionably an immersive experience for Xander, but really only one that he could enjoy. And we can't really afford to give everyone a virtual reality headset. And even then, it would be really difficult to program them all so you all saw the right bit of the hologram. So you guys saw it from the front, you guys saw it from the side, and then the people on the gallery saw it from the top. So ideally, we need to find a way of projecting our image into thin air so that you could all see it. But it turns out that this isn't possible. Nobody has found a way of doing it yet. Now, I know what you're thinking. Didn't Michael Jackson appear as a hologram at an awards ceremony in America? Or a holographic 2-pack at a music festival? Well, yes, they did, but we looked a little bit more closely. And it turns out they weren't actually solid 3D shapes. It was all just a magic trick. Let me explain. And this is a nice simple hack you can do at home. Just take an old CD case, if you still have one of these at home, and just make sure it's not too many scratches on your CD case. Now, what you can see on my case here is I just have some black card just to keep it open at 45 degrees. Then I'll need a smartphone to take a movie. And we've just taken a movie of Dallas, who's going to be our hologram. And of course, you can take it of anything you like, your friends, your dog, but just do it on a dark background. So what we should be able to see here, if I just turn this around, okay, can everyone see that? So you can see my hologram, and it looks like I could just tickle Dallas as well, like this. Oh, he must like it, he's waving. Good. But actually, we can see it from this angle, and it looks fantastic. But if Dave, the cameraman, looks from where I'm standing here, you can see Dallas isn't really there. So it's all just a hologram. But we've made our own holographic projector, and this is something that you could just do at home. Now, we could scale this up and perhaps use a flat screen TV like the ones you might have at home. And this does get us closer to our goal of a hologram in midair, but it's still really only a magic trick. He's not really here. I'm not really tickling him. So it limits how well we can visualize and manipulate objects in 3D space. So ideally, we want to be able to stand next to our hologram. So I want to have Dallas just standing next to me here. I want to be able to make eye contact with him. I want to be able to shake him by the hand. And we can't really do that with a magic trick. But there is a company in Surrey that's taking us a step closer to our goal. They use a curtain of mist to display images that float in midair. Sounds great, doesn't it? So, can we bring in the fog screen, please? Now, this is a high-tech version of the technology that you'd find in a cooled air humidifier. Tap water is pumped into a fog tank where it's blasted with ultrasound, turning it into a thick fog made of tiny water particles. So it uses this mist to display the image. So this doesn't actually create our image. We need a projector to be able to do that. So I think we're ready to beam Dallas into the lecture theatre with us. What do you think? Yeah? Brilliant. Okay, Dallas, are you there?
I think so. Where are you? Where am I?
You need to turn around down this side. Brilliant.
Who am I?
Excellent. We can see you. You look fantastic. Now, Dallas.
Yes.
I think you are the first person to appear live as a hologram at the Christmas lectures.
I've got to say, I'm really excited because when I was young and I used to watch the Christmas lectures, the whole idea of holograms was this wonderful symbol of future technology, so I'm absolutely thrilled. And how's the lecture going today? How's it feeling? How's it sounding?
I think it sounds pretty good. What do we think?
Is it good? Is it good?
Right. Well, what I'd really like to do is to give you a hug. But I can't quite do it, I'm afraid, Dallas. So it would be really nice. But what about just trying to shake your hand?
Okay.
Okay, so here's our robot hand from earlier.
Yes.
And we should be able to shake hands with you. So I understand you've been sent the glove as well?
Okay, Dan. Well, I've got my controlling glove on.
Brilliant. Okay,
Should we
give
have
us
a
a
little
wave.
Oh, hang on. I've got to switch it on here. Here we go.
Oh yeah,
Hey,
we can
look at
see it.
that.
Fantastic.
It
So you are controlling that. That looks brilliant.
That is
Okay.
Hi, everyone.
So say hi. Hi.
Hi.
Brilliant. Okay. Now, waving's easy. I want you to be able to hold the ball that I'm going to give you here. So are you ready?
Okay, so I'm gonna open my fingers. I'm gonna.
Yeah. You ready?
Yeah, I've got it. I think I've got it.
You have got it.
Oh, look at that.
Fantastic. Well done.
I'm gonna try and crush the ball.
Okay, squeeze the ball. Now you can drop it.
Okay, I'm gonna try and drop it. Ready? Here we go. Boing.
Excellent. Well done. Now, this is all about communication. So who would like to come and shake hands with Dallas? Oh, so many hands. Wow-wee. There are lots and lots of hands. Me. What about you there? Okay. Okay, what's your name? What's your name? Rupert. Okay, Rupert, if you stand this side, okay?
That's a good looking shake. I feel like I'm in every sci-fi movie ever made right now.
Are we ready, Dallas?
Okay.
Are you ready to say hi to Rupert?
There we go.
He's going to try and shake you. That's it.
There we go.
Yeah.
Look at that. How do you
Brilliant.
do? What a pleasure to meet you. This is a first for the Royal Institution.
Now, can you feel Dallas shaking your hand? Yeah? Yeah? He's not too rough, is he? No. Okay, I think we better let go of Rupert's hand, Dallas.
Okay.
Brilliant.
There we
Okay,
go.
thank you very much, Rupert. Bye. Say bye. Okay, this is incredible, but we're still a little way off our ultimate goal. So we're going to come back to you later, Dallas. Is that okay?
Okay, I'll see you in a bit.
Brilliant. Bye.
Bye.
Say bye. So, step 3 complete. We've managed to capture our hologram, we've transmitted it, and we've made Dallas reappear in the theatre right beside us. And we've even been able to reach out and touch Dallas with our robotic hand. But we still want to go one better, because we still needed that robotic hand to actually do the handshake. So again, the question, how do we touch something that isn't there? Well, to help us answer that question, please welcome Sarah Bailey from the University of Bristol. Hi, Sarah. Hi. Thank you. Okay. And I know you've brought quite a wonderful contraption with you here. So we just get it in place here. Okay, so what is this back end of a cow designed to do?
Well, this is the Haptic cow, and it's designed for teaching veterinary students. So I'm a vet, and I've spent many years trying to teach students how to palpate inside a cow, which we do to diagnose pregnancy and things like that.
Okay.
The problem is, in the real cow, they can't see what I was doing when I had my hand inside, and then when they have their hand inside the student, I can't see what they're doing, so I can't teach them.
Ah, okay, right. So could I have a go?
Of course, please
Brilliant. Okay, so I'm one of your trainee vets. Okay, so what's happening
if
here,
you
Sarah?
move your hand down and you come on to, that's the pelvic floor, so it should feel quite hard.
It does,
because it's out of bone.
Okay, yeah.
And then if you slide your hand forward and you will drop down,
Oh,
yes.
Yes, I did.
And that's going from the pelvis into the abdomen or the cow's belly.
Right, okay.
If you then lift your hand up and back towards that yellow dot, and how about we get the cow pregnant?
Okay. Sounds good.
So magically she's now pregnant, and if you drop your hand down onto the red structure, go forward a little bit, and if you go left to right, the cow's uterus has what we call 2 horns, or 2 sides, and this cow is pregnant about 8 weeks on the left-hand side. So the left-hand side is bigger, the red object there. And also, if you just press onto it, you should feel it's a little bit softer.
It does. It feels, yeah, that feels soft. And you can also feel these two bumps. Yeah, so you can feel that this left-hand bump is much bigger than the right-hand bump as well. Yeah.
So the baby calf is on the left-hand side. That's why it's a bit bigger. And the softness is the fluid, like the waters of pregnancy.
Right, yeah. So I can push down and feel like I'm pushing down on sort of a bag of liquid sort of thing.
Yes.
That's how it feels. Excellent. That's really good. But I want to see what's inside. Can I have a look what's inside?
Should we swap round?
Yes, please do. All right. Let's have a look at what's inside here, everyone. So, Sarah, talk us through. What are we actually seeing here?
So there's a little robot inside. This is virtual reality with haptics. And the motors of the robot generate a force feedback, which allows you to feel objects of different shapes and sizes, but also of different firmnesses. So the bone felt quite firm, whereas this area here felt quite soft.
Now, what happens if one of your trainee vets pushes a little bit too hard on the cow?
Well, the cow can have something to say about that.
Excellent. Yes. I don't blame it. Okay, that's great. Well, thank you so much, Sarah, for bringing this in and showing this wonderful technology.
Thank you.
Thank you. Now, I never thought when I was going to do the Christmas lectures I'd actually have my hand up a cow's bottom. So we all have different things. Now we know it's possible to feel that you're touching something that isn't there. When I was doing that, I truly thought that there was something there, not just a little robotic hand. Now, you may have heard a word there that Sarah used called haptic. That was her haptic cow. And it's probably not a word you're familiar with, but actually haptic devices are everywhere. If you're typing on your phone and it vibrates when you hit a key, that's haptics. That sensation of touch is being stimulated by sending a vibration to your fingertip. Now, another haptics device that I want to show you right here in the studio is quite unbelievable. In fact, it's so unbelievable, I'm slightly worried you're not going to believe me. Until recently, the haptic devices relied on a kind of arm or robotic surface, like we saw with Sarah's cow. So you could apply a force to your hand. But there's a team in Bristol now developing what they call ultra haptics. Now, this box sends ultrasonic vibrations into the air so that you feel objects as if they were hanging in thin air. So who wants to give this a go? Oh, there are so many people. Okay, what about you right in the middle there? Yep, you. Okay, what's your name? Ethan. Hi, Ethan. Okay, if you want to stand here. Okay. Now, what we're going to do is try and guess some shapes here. Okay. Now, this is actually going to create a noise, so we can't talk whilst you're trying to guess that shape. Okay. Right. So, what we're going to do is put the picture on the screen so everybody else can see it, and then I want you to guess if the object is either a cone or a square. Okay, so they are your two choices. Okay, are we ready? Okay. Right, so let's just...
Is it a cone?
Let's have a look. So, say that again.
A cone.
We think it's a cone. So, can we see? Yeah, and that's what everybody else can see. It's a cone. Excellent. Well done. Well done. What we have are 256 tiny speakers, and they're creating ultrasonic vibrations, so they're outside of the human range of hearing. So we can't hear them, but Ethan can feel them. And it's like that feeling, you know, when you're near a very loud bass speaker, So you can feel it in your chest. So it's like that, but much, much more precise. Okay, so we should have the second shape loaded. Okay, but this time, I think you can actually look at the screen as well, because I said it was either a cone or a cube, so we know it's a cube this time. Okay, so just to give you that sensation, start again, and then you can look at the screen at the same time, and you should be able to see your hand. And does it feel like a cube?
Yeah.
Could you feel the difference between them? Yeah, that's brilliant. Well, thank you very much for your help, Ethan. Now, I think that is an amazing piece of technology. Ethan was just looking at shapes and guessing what they were when we couldn't see anything. It was unbelievable. And maybe in the future, that Ultra Haptics board, combined with our holographic projector, could create an image that you could shake hands with for real. But what about our other senses? Is there anything we can use to share tastes and smells with someone a long way away? Well, this could be the answer. This is the world's first electric lollipop. And it's been developed by researchers at City University in London. Now, this has actually been designed to do this. So this is not something that you should try at home. And all you need to do is put your tongue between these two electrodes. And what it will do is simulate a whole range of basic flavors. So salty and sweet, or minty and spicy. So who's hungry? Oh, wow. Who would like to share a meal with Dallas? Okay. Wow, there's lots of people. How about you in the green jumper there? Okay, what's your name?
Zara.
Zara. Okay, Zara, if you just want to come around this side, okay? And what I'm going to do is give you this, and we need to wait for Dallas as well, because we've given Dallas a lollipop as well, okay? So we need to be able to bring Dallas in here as well. So hi, Dallas.
Hi there.
Hi. We've given you a lollipop too?
I have it here, yes. It doesn't look very appetizing, I've got to say.
Yes, I think Zara feels the same here as well. Now, okay, I want you both to place your tongue between the prongs here. Okay?
Really?
Yes.
Okay.
Now, of course, like I said, you don't do this at home. This is being specially designed for this. Okay, are you ready? You take it off me. Okay?
Zara, you
Put
go
it on your
first.
tongue.
You go first. I'm going to wait to see what happens.
Okay, you ready, Dallas?
Okay.
Now, you should be able to taste a flavour. Give you a little time to think what it is.
Lemon.
Did you taste that, Zara?
It's from sherbety.
Like a sherbety, is it? Yeah?
I think that tastes quite minty.
You think?
Yeah.
Minty? Do you think it could taste a bit minty?
Yeah.
Try again, yeah? It is actually minty. That's what
It
it's
does
meant to be.
taste
It's minty, yeah. Can you taste a bit of mint in there? A bit like toothpaste, maybe?
Yeah.
Yeah? Maybe that's where you're getting the sherbet sort of taste from. Okay, let's try another flavour.
Okay.
Okay. We can program this to give us another flavour, please.
Do you have Christmas dinner flavour?
All right, now we should have a second one programmed. Are you ready?
Okay.
Now, this should be slightly different, slightly stronger. So just put it on your
God,
tongue.
that is strong. Wow. Oh,
Is it strong?
It's quite sour, yeah.
Do you get sour as well? Is it very sour?
It's quite sour.
Is it? Yeah.
I think that one is the one that tastes lemony.
Do you?
Yeah.
What do you think, Zara?
Yeah.
Think that could be lemon? Yeah. So that's much more sour. Does it taste different between the first and the second one?
Yeah.
Yeah? So what's happening is that device is sending small electric currents through those prongs. So it's stimulating the taste buds on the tongue. So by varying that current, we can vary which of the taste buds are being stimulated and what flavour they can taste as well. What do you both think of that experience?
I don't think the inventors are going to win MasterChef just yet, but I think it's a really interesting technology.
Well, they might not be winning it because it's well known that we rely heavily on our smells to help us distinguish between tastes. So we have another device for you to try. Are you ready for this, Zara? There is a device called a Senti, which attaches to your smartphone just using the headphone jack here. So the idea is people can send you smells over the internet. Now, I know what you're thinking. Do I really want to be able to smell my friends? Probably not. Well, it's okay for the moment because we don't have that many smells. We only have a choice of 10. So you're going to have no nasty surprises. Okay. Now, Dallas, you should have one as well.
I've got mine here, yeah.
Brilliant. Okay, so what we're going to do is I'm going to try releasing a lemon smell to you as you have the lemon taste on your tongue. Okay? And this is really cool. We need to see this coming out here. Are we ready? Mm-hmm. Okay, let's try this. Lollipops at the ready. And sniff. Can you sniff it? Yeah? Can you smell that?
Yeah.
What does that smell like now then?
It makes it more like lemony.
It does make it more lemony, yeah? Do you get that sort of lemon sherbet sort of taste out of it now?
Wow.
Yeah?
Wow.
Dallas, what do you think?
I think it's amazing. You get a proper little sort of jet of scent. And yeah, it is very sherbety, but it also makes the taste, a lot more vivid, I suppose, if that's the right word. A lot more obvious.
Does it feel more real when you have the taste and the smell there?
Yeah, because like before it was like, I think it was just more sharp and...
Yes, it's more sour, isn't it, when it's just the lemons, where now it's a bit more like a lemon cake or lemon sherbet, isn't it?
I think sherbet's exactly the right word, because this actually gives you that almost that kind of fizzing sensation on your tongue.
Brilliant. Okay, well, thank you very much. I hope you enjoyed sharing a meal together, a feast of lemons. Thank you very much, Zara.
It's a pleasure. Thank you, Zara.
Now, we chose to share that experience with Dallas because he's someone that we all recognise. But Dallas is really just a stand-in for me, for my grandma, as she's the person I'd really like to feel close to. Now, it's clear the technology isn't quite there yet. We can't actually touch our hologram, and it would be nice to eat something other than lemon sherbet. But we're getting close. I started this lecture by showing you the communication breakthrough that Alexander Graham Bell made 140 years ago, and look how far we have come. Imagine how we'll be communicating in another 140 years. The tools we need to achieve our communication dreams are all around us. And it will be the job of the next generation of engineers and scientists, people just like you, to perfect and combine these technologies and hopefully bring us all closer together. In my third and final lecture, I'll be looking at the motor and how we can use electricity and movement to make the world's greatest robot orchestra. But until then, good night.